introduction. To give an introduction in deploying 23903 for the representation for modeling, design, integration, and interoperability of multi-domain systems, having in mind that the personal health information management is by nature a multidisciplinary system and therefore a multi-domain system. Contrary, for instance, to communication between departmental information systems, etc., there is the focus just on data, on technology, and the technological representation of data and relationships, algorithms, etc., and that's all. Okay, please interrupt me immediately if there's something not clear enough or there are some questions related to the presentation. The first I would like to do, and this introduces into the challenge to ISO TC215 to address different aspects supported by 23903. The reason to develop those things was the move from organization-centered information systems for supporting departments and administration towards an open architecture for healthcare settings, including cross-organizational collaboration, etc. And this was connected to the paradigm changes of practicing medicine. Traditionally, and this was also defining, you will see thereafter, the standards we developed, we addressed the healthcare aspect by an empirical approach. That means specialists within their organization, an hospital or a practice, performed domain-specific general services, for instance, as a family doctor or as an eye doctor or a cancer expert or whatever. And he performed based on experience and observation what worked to get yesterday, performed also today. And he addresses any patient coming to this practice or hospital. This was then advanced by organization-centered local services supported by evidence-based medicine. That means it was not just a personal observation performed by the health professionals, guiding him and feeding the experiences. Here, we used also the experiences and outcome of other health professionals stored in domain-specific, group-specific databases, for instance, the outcome of heart diagnosis and treatment or others. And so he could check his own observation and justification, his own diagnosis and therapy, and could thereby evolve, learn, but also share his own experiences with that knowledge space. That means that database. But it was still focused on specific diseases the doctor was qualified for. The next level was then, and this was addressing, of course, disease-specific groups, because the evidence-based database was always established for specific diseases. Evidences about heart diagnosis, heart disease diagnosis and treatment, or eye diseases or whatever. And so far, the target was a disease specifically defined group. The next level of care procedures was the cross-organizational service provided by health professionals for caring an individual with a specific multidisciplinary disease by the different experts, such as cancer. Here we have to address specific diagnosis, such as imaging. We have to consider biochemistry or physiology. We have to address pathology, a specific domain to be included here. We have to integrate also social care, aftercare, and many others. And here, the target group is the individual with the concrete process this individual needs, and this is managed care. The next level,
which
yeah,
this is where we saw a rise within provider organizations of someone who was able to look at all the multiple disciplines, look at the individual as a complex system.
Yes, but for a specific disease, that means, for instance, for cancer, also as a managed care process. It's not addressing the complete health. Okay, the next level, and it was finally still based on the empirical phenomenological medicine approach. That means they performed the different procedures, but they did not all things by themselves. They collaborated with other experts for different contributing disciplines, and so guiding the patient through the process with all the steps needed, for instance, in cancer care. And so, and this was also accompanied by the development of cancer registries, storing the information about the different procedural steps, about all the patients managed there, etc. And then it was used to enhance the evidence-based medicine for cancer, etc. The next level is the personalized medicine. And here we have distributed local and remote services. Formerly, each health professional was performing, and then the patient was sent in the person-centered medicine to the other organization, the other institution, to perform their special step. And here we have distributed services. That means we are considering the same patient from different perspectives and are contributing perhaps to the same step with the different aspects. That means not just delegating him to the next institution, to the next organization performing there. No, they have been collaborating directly, contributing with their knowledge. And this includes not just regulated health professionals, but also laymen, because you need also input from the patient, from the environment, that means the family, etc., and also technical systems directly integrated and contributing. And so we have individual personal disposition of we are carrying an individual and personal dispositions from the different perspectives of collaborating domains. Not just having a chain, a procedure, but collaborating directly. Okay, and the next level is to move up from the phenomenological approach. That means observing, learning from experiences and using this to a distributed cross-domain service by understanding what happens inside the patient. That means what happens in the body, in the organ, in the tissue, in the cell, how it is impacted by environmental conditions, social conditions, occupational conditions, or also behavioral aspects, etc. And so understanding the course of disease, you're understanding the pathology. And so you are able not just to prevent in generic ways, you can even predict, and by that way clearly prevent specific diseases, because you understand what happens and how can we intervene in that process. And this results finally in ubiquitous personal health. And now I come to the issues to be addressed in TC215. For managing communication and cooperation, also storing observation in local data repositories such as electronic health records or personal health records, the doctor performs, or the nurse performs, observations and represents those informations in data, and the justification of those data is the pattern recognition. This was the case last time, it works very well, and this is the same this time, etc. And this is then stored in local data repositories inside the unit. And if we advance to evidence-based medicine, then we are justifying this by data from data repositories stored to justify group-specific treatment outcome or other information. And if we have to combine data from different organizations in different contexts, It's not enough to define data. That means data standards. We have also to define the interpretation of those data. That means the information. That means for that level, we needed information standards, not just sharing data, just a figure and a unit and nothing else. If we move to person-centered medicine, so far, we have always been focusing on the same disease, and therefore there have been relations between education and experiences and so of the practicing actors. In other words, it was just one domain, but you have to define how to store the observation, how to communicate it, how to reuse it, etc., and to understand what's meant with that data. If we move to person-centered medicine, we have to bridge between different organizations and different disciplines contributing to the care process. Therefore, we have to manage two aspects. First, how to manage the process. When it is needed to send now the patient to the other side, what is requested to be performed there, etc. That means I have to understand the process, the underlying services in the process, and the management of those processes. And I have to bridge between different domains and institutions, even different countries, to contribute to this care process. And therefore, I have to agree on the representation of things, not just sharing data and saying this is the interpretation of this specific data. We have to agree on terminologies and disease management best practice guidelines. And therefore, starting with data standards, we are still defining data standards and information standards. We have to move towards terminology standards and process standards. And this is what we are doing at the moment more and more. We started earlier with terminologies, but we have still open issues. If we move to personalized medicine, we have to understand the pathology of the disease. And this means that I have to investigate everything from a clinical, scientific, multidisciplinary perspective in a situational context. And understanding things is not just having an observation and sharing data. I have to understand what happens, in which element, what functions are ongoing, what are the dependencies, constraints, and relations to others, etc. That means I have to manage the knowledge describing this system of a patient and its environment for this specific condition. And for representing knowledge, terminology is not sufficient because terminology just provides terms, but not declaring how the different terms are interrelated with other terms, just as in hierarchy, but not, for instance, in functional dependencies or other dependencies. And this is provided by ontologies. And therefore, I need ontology standards for all contributing domains. And if I move up to 5P medicine, I have to combine those different domains and the knowledge representation, not just understanding the cancer. No, understanding the cancer in the context of occupational conditions, of environmental conditions, in a behavioral context, etc. And therefore, I have to represent scientifically justified the individual status from the perspective of multiple disciplines, representing their concepts in a comprehensive context. And this is not just one knowledge domain with one ontology, for instance, the gene ontology or the cancer ontology. No, I need the ontology of health and social care with all the contributing disciplines, and therefore I need multiple ontologies and an organizational framework to interconnect them, to interrelate them, and this is the top level ontology. And I need standards to address this. And I have to say, TC215 so far still focus on data standards and information standards, pushes terminology standards. In process management, we are quite weak. We don't tackle so far sufficiently or at all domain ontology standard, and we do not address multiple ontologies and top-level ontologies. I have to say, I'm since 25 years member of the Open Basic Ontology Foundation, and I was partner in developing all those things, also the top-level ontology standard 21838. And I have to say, I'm sure that just a few in TC215 know the standard, but this standard is the top-level framework guiding us in our future development. Okay, and I guess this is very important, that we have to advance from our specific focus, technical focus, or the C-specific focus, to a universal focus. That means considering all those different things in a complex environment with all the relationships, dependencies, etc. And this turns health from reactive care, that means observing and then responding, to proactive understanding and therefore knowing how to behave to avoid those problems. And the challenge is to understand and to formally and consistently represent the world of sciences and practices. That means the processes, the different technologies, the methodologies deployed by different domains, the language they are using, because they are using specific languages for the same issue and have also overlapping concepts. And we have to represent all those different things and put them in the right relationship and order. That means we have to describe the system from a universal multidisciplinary perspective. And this requires first that I have to understand how to represent such complex, dynamic, multidisciplinary systems, how to represent the knowledge characterizing the different system elements and the domains contributing to that system, then the way to model them in the development process up to ICT applications. And in that context, I have to manage the language problem, because the biologists, the physicists, the chemists, all of them are using their own language, their own representation styles, formula, language, Latin, whatever. The IT experts are using their language, and even there we have big differences. BPML for the process experts, or UML to represent information or data representation. And here new developments such as fire are coming in. And I have to bring all those different things together, and the system-oriented, architecture-centric, ontology-based, policy-driven approach of ISO 23903 provides exactly this framework to address all those aspects. Yeah, and this allows us to move from exchange of data to share knowledge among all the different partners and disciplines involved, and even considering the different skills level, because not every doctor has the same experience, the same education, but we have to enable that everyone can perform in the best way. And therefore we have also to tailor the solution considering the skills of the individuals in that context. For instance, enabling what we have demonstrated with 23903, that a patient using street language is talking with the doctor using Latin, and both can communicate and understand each other, because the concepts have been formalized and then translated, if you want. And so the idea behind, that means the concept represented in different language, has then been mapped, and so they can communicate and cooperate. Okay. This is very important. And again, if we try to harmonize standards or subsystems at data level, we will fail. We try doing this, for instance, in harmonizing ISO 13626 with the HISA standard 12967 or other standards, and there have been negotiations over 6 years without any success, because each project team said, my specification is correct, the other have to adapt. No, the solution is, because I will never say the physicist is right, or the chemist is right, or the biologist. No, all are right in their specific domain, and I have to bring them together. And everything makes sense. And I would not say, I will not train a biologist in biology, but he has to learn UML. And no, he is expert in biology. And I use this knowledge to combine it with other knowledges. And this has been done with 23903 by formalizing the specification and then being able to map them correctly. And now let's have a look at working group 11. If we consider our challenges and projects, we can distinguish different scenarios or project types. One is developing a personalized health navigation architecture. And this is a generic approach to the entire system. In other words, I'm not focusing on a specific parameter, a specific sensor, a specific assessment of specific data. No, I try to improve the personal health by enabling the navigation through the system and the circumstances by all actors involved, including the patient or the citizen before becoming a patient, and all carers, nurses, social workers, doctors, whatever. Another is representing relations between different aspects: digital health, digital medicine, digital therapeutics. And this is addressing specific domains and their relationships, but not the entire system and procedures in the first round. But this will be addressed if we have specific disease management programs. Here, we are focusing, for instance, on one specific disease and therefore specific domain, but also including subdomains or other domains supporting this. For instance, if I have cancer care, I have to integrate social worker. I have to integrate environmental medicine and other aspects, but the main focus and therefore the controlling domain is cancer and accompanying issues such as genomics, etc. And here, the process management is important. That means defining the core elements and the relationships in a procedural way. And other things are focusing on specific services, such as personalized health services for supporting fitness trackers, cardiovascular risk management. That means the Apple Watch watching my heart rhythm and other parameters, etc., and giving then signals if I have a level beyond the safe environment. That means I'm running into risks and therefore I have to respond, I have to visit the doctor, or I have to interact or whatever. These are the different scenarios, and all of them can be represented in 23903, but the way to tackle this is different. I will not go into the details here. I have already explained what the scientific basis for the 23903 approach are, such as universal type theory, universal logic, ontological representations from the top level, ontology level, etc. This is not important, but I have to understand we are addressing the personal health system. The empirical approach was, there is a patient and something happened with the patient, and this is the outcome of the patient. That means my observation as a consequence of a specific disease. That means it was an input-output relationship to assess that something happened inside the patient, inside the body. And I could describe it in data, observations, whatever, but I could not understand how the input-output relationships have been impacted, transformed, etc. What has happened inside the body. And this holds not just for one system, but also for the relations between different systems. For overcoming this problem of black box approach, I have first to understand what is inside the system. I have a patient, and the patient consists of organs. In the organs, we have the tissue. The tissue, we have the cells. In the cells, we have the subcells, etc., up to elementary particles. And they are performing specific functions and are interrelated, constrained, impacted by others. And if I understand the system in structure and functionality behavior, then I am able not just to observe, but to understand and to predict what happens there. And this is exactly the approach we are looking for. And therefore, it's inevitable that we have first to provide an architectural representation, because if I move from the black box to the white box, I have to describe the components, the subcomponents, the relationships between all the components, how a component is composed or decomposed, etc. And these are characteristics of an architecture. In other words, if I immediately start with the data exchange or information exchange, ignoring the processes, the architectural aspects, that means structure and behavior, I cannot understand, I cannot intervene and correctly react. In other words, I have to introduce architectural standards to correctly use data standards, information standards, etc., because otherwise I'm sharing things and everyone is performing with different perspectives, believing this comes from that point or from that or whatever. And this is the reason that we have the reference architecture plus a process definition plus the development of knowledge representation, etc., in 23903. And this is the outcome. That means we have to describe the system in question, for instance, personal health system. And this is characterized by different domains representing their perspective on personal health with their language, their terminologies and methodologies. And as I said, it could be the clinical part, it could be the social aspect, it could be the environmental aspect, it could be a specialty such as physical or chemical or other disciplines, considering the subject of care and the aspects there. For understanding, I have to understand how the system in question is designed, composed and decomposed, which functions are performed at which level and how they are interrelated. And therefore, I have to provide an architectural composition, decomposition for each domain. The domain in biology, starting with the body and the organs and the tissue, etc., or for social aspects, etc. And if this has been done and I correctly described the system in question, for instance, personal health, with the patient in the center, and then the actors involved, etc., technologies to be deployed, etc., then I can develop a solution to support that process. That means understanding the biology, the clinical aspects, etc. I can then define an ICT system with specific services to support those processes. Then I can define the informational representation to enable those IT services. Then the data representation to provide those informations, and finally implementing that solution. And this is the different viewpoints perspective or dimension. And the challenge is that for all levels, from the data level up to the real world systems level, I have to represent the representation of the system from different perspectives. That means domain knowledge or different viewpoints in the development process, and have to formalize that knowledge. And here, ontologies are coming in. And again, we cannot perform this without a certain focus on TC215 on ontologies. So far, we are just at the beginning. And I have to say, for security and privacy, we had to bridge between different policy domains. And therefore, I have introduced, as the project lead of 22600 already in 2000, the 23903 approach to bridge between different policy domains and their different concept and knowledge representation to manage privilege management and access control properly. But this was the only standard I'm aware of addressing issues in TC215 with an ontology behind. This was the policy ontology, the first ontology we have developed. Okay, and if I have to tackle knowledge representation, now we see the challenge. First, I have to understand the reality, and this is the epistemological level, performed by domain experts, the biologist, the clinician, the nurse, all the others, based on their understanding of the different domains they are representing. They describe this in the way of a textbook or whatever, what happens there, how it is built, how it is interrelated, etc. And again, every different domain uses their own language and methodologies. In other words, I cannot transform from one to the other easily. I have to provide a notation to enable that I can represent the concepts formally and universally to be able to map them. And this is exactly done by learning from type theory and universal logics. And then we can represent this first to enable communication between the different parties by translating their knowledge into the other representation style, and also to develop solutions to support the processes with ICT. The next level is then that we have to run such processes in computers. And the computer, contrary to the nurse and the doctor, doctors talking Latin, using natural language, etc., the computer is saying yes and no, 1 and 0. That means the processing level is a way to compute those different concepts in an easy way. And I have to define the data representation and the algorithms performed, and again, in an efficient way. And therefore, I have to transform the real world complexity into such a simplified representation. In other words, the language is getting more and more simple. As I said, from the Latin and the natural language, the BPML, which is already constrained, up to the level bits and bytes. And I have to know I can everything represent in bits and bytes, everything. But if I have to decide to connect this data element with that data element, I cannot do it at the data level, because this is defined by the concepts and by the disciplines. Is, for instance, this biological observation connected with that chemical reaction and that social impact? I cannot do this at data level. And therefore, I have always to go back, if I like to provide interoperability at data and information level, to the business system, the use case, and the real concepts behind to decide the right relationship, the right representation, and the right connections. And this is frequently missing. In other words, we have frequently connected fire resources which don't fit together, and also using different fire resources for the same concept, because it have been different teams developing different representations of that thing in different fire resources. And we have to overcome this. But the advantage of 2393 is that there's no need to revise anything, because if I place anything existing in the different elements of 2393 architecture, and then I develop the entire process from the real world representation through the different viewpoints, I can then correctly place, correct, that means adding things, missing things, or changing things in the elements, and correctly interrelate each element, coming to a correct, consistent solution. In other words, even wrong specifications, wrong fire resources or others can be reused. I can interconnect HL7 version 2 with CDA and HL7 version 3. Everything mediated by 23903. Yeah, and of course, I have always to check, not at data level and not at specification level, that means the knowledge representation notation, but at the level of reality, if my representation is correct or not. And if I have checked this, and therefore it's always a top-down approach, and if I have defined things, I have always go back to check if this is correct, and then I can run the process. In other words, so far TC215 has been focusing on data, then advancing to information, considering also the semantics, but we have to advance to knowledge of each of the included domains. But this is not enough. We have also to consider the knowledge space, the dependencies of different disciplines, how they are impacting each other, etc., to take the right strategic and operational decisions. And this is very important. And as I said, I have always to check my representation up to the data level on reality if this representation is correct. And if I develop anything, I have always to go back to the experts. They have to define the terms. They have to define the dependencies. Then I can transform it into IT representation. I can implement this. Frequently, I met ICT experts which developed a system for pathology analysis or whatever. And they never heard something from a hospital. They have never been inside the hospital, but they wrote an application. I wouldn't like to be a patient in such an environment. Okay. A very important aspect is the knowledge representation based on different knowledge language levels. This is very important. As I said, the representation for processable information in computers is a very simple representation, data representation, schemas, and finally it's running in yes or no, bits and bytes. For deriving those data representations, I have to understand what is meant with the different data. I have to represent the information represented by those data. Then I have to understand what is represented by that information as a concept, and it's getting more and more rich and complex. In other words, the natural language is able to represent anything. And therefore it's able to represent knowledge, sharing knowledge, skills, etc. But we have then also to enable enough ways for decidable representations, etc. And we have to implement this finally in IT environment. And therefore we have to run for all the different language levels, knowing that the decision and justification can only be done at the highest level, recursively enumerable level. The computer is running with regular languages, and here I can just represent and have to believe. I cannot check if this data is in the body related to that data. Okay, and this means if I have to present the real system and its representation in IT, I have for each viewpoint to present the concepts, because also the information viewpoint is a space of concepts of informational elements. And each different viewpoint has to be represented by ontologies. In other words, the real world is represented by domain ontologies using general logic, description logic, etc., frames, formal languages. The data level at the end is represented by data models, XML schemas, database schemas, etc. And both are ontologies for their specific viewpoint, the real world business viewpoint or the data viewpoint. Or if I have to deal with information, then I have thesauries, taxonomies, informational hierarchies forming the ontology of the information view. In other words, all those different viewpoints have ontologies and have always to transform from one representation style based on that ontology into the other up to the implementable level. And this is the top level ontology. And yesterday I was asked at CEN, if we don't have for a specific problem or project no ontologies so far, how can we perform? And I said, then we can borrow from the top level ontology, because this defines the basic elements of each ontology, gene ontology, social ontologies, ethical ontologies, whatever. We have always an entity. This entity could be a continuant entity. That means this is permanently present, static, or an occurrent. That means it is changing. The continuant entity could be independent or generically dependent or specifically dependent, etc. While the changing entity, the occurrent entity, is depending on specific processes, process boundaries, temporal regions, whatever. And this can be specialized more and more. And so I can form a starting ontology for any issue I have to address. And of course, then the experts should sit together to define the elements and their relationships to be consistent and correctly representing the reality. Yeah. And now we are at 23903. It provides an interoperability integration reference architecture, but it goes beyond. It allows to develop systems consistently right from the beginning if you have new systems, but you can also adopt existing systems, technical systems or standards or specifications with others by integrating them in 23903 and thereby by re-engineering them, correcting everything. In other words, without revision, you can reuse everything in a correct way. And so it is a model for designing systems, generic systems, for instance, a framework or an architecture, or also for providing a process solution or for providing individual technical implementations. Yeah, and here we see starting point has to be the top level. That means the representation of the business system, the patient, personal health, social care, whatever. Defining the domains involved in that system, biology, clinical issues, specific clinical domains such as cancer or heart or whatever. And also other domains such as technology to support everything or environmental aspects or whatever. These are the domains to be named. And then we have to define the architectural composition of each of the domain. And this is done in a generic way for defining, for instance, a reference model or an architecture which covers any thinkable use case, or it is specific for a specific use case, and then defining just the domains and subdomains relevant for this use case, full stop, simplifying that approach. And if you have understood by domain experts the matter of the business and the objectives, then you can transform it, first defining the general framework of the IT solution, the system, the IT system with its services, the informational representation of each of the services and elements, the computational, that means aggregation of the elements, and the engineering viewpoint, that means the data representation for implementable artifacts. And the technology viewpoint covers the maintenance of such systems. In other words, if you have to design a reference architecture or an architecture such as the personal health architecture, then you have to focus on the business system and the domains involved in. If you have to provide a solution based on existing artifacts, such as fitness tracker, etc., then you have to check the existing elements, have to place them in the right viewpoint and in the right domain they belong to. Then you have to start with the business case, the use case, have to transform it into an ICT service representation, an informational representation, etc. And if you arrive, then you have to see, does your element you are reusing fits the definitions of the concepts for this viewpoint, or must it be adapted for this specific case? Again, not requiring revision of each standard and specific, just adapting this, and this can be, because it's formal, can be automated, and then you can interrelate, correct the elements, the fire resource or the data model or whatever, and correctly interrelate it with the others. And then you are able to derive your solution. It's very important that if we have anything guiding us, such as the European EF interoperability framework, this is a layered architecture, but in reality, this layer doesn't exist in that way. And therefore, you have to re-engineer this to make it manageable. That means to make it correctly represented and then manageable for practical solution, for integration, for interoperability, etc. And here we have used 23903, placing the different layers either as domain or as a specific viewpoint. And then we can directly reuse it and can integrate specific standards and specification to run a specific solution. The same holds also if we have to address security, privacy, or ethics. We have to represent our system with the customer, the service provider, and the policy ruling the behavior of that system. And the behavior of the system is impacted by personal wishes of the user, or by legal requirements, or by contextual aspects, or also by process requirements, the process policy domain, because you cannot run a process against specific practices for physics or for clinical affairs or whatever. You have to bring all those different aspects together, first formally representing them, and then mapping them correctly for your specific use case. And so you can see even ethics is possible to be managed and considered for each use case. And meanwhile, I was involved in that team. We have developed in IIIE the ethical policy domain ontology, and we have the policy ontology, etc. Yeah, this is an example of the policy ontology we developed in the early 2000 in 22600. It was the first ontology in ISO TC215 to define a standard specification. And of course, you can then place everything you like to integrate, to reuse, fire resources, archetypes, concepts, or whatever, in the right viewpoint, looking for the right domain a specific fire resource is representing, and then you can re-engineer those existing elements for your specific solution, and so you're always on the safe and correct side. Thank you so much.
So thank you very much, Bernd. For the 22600, that's a multi-part. Was that in -1, -2?
No, this was 1 and 2. That means 1 was the general principles and the formal model was the cube in part 2.
Okay, in 2. Okay.
And then part 3 and 4 have been practical examples and implementations. For instance, then we have reference to existing standards and said how those standards can be then reused in that framework.
Yeah. Okay. A second.
Okay. Are there any questions?